Okay, so we are getting into our next unit, and we're going to be talking about circles. We're going to be talking about diameter, radius, circumference. We're going to start with vocabulary, and then we will move into finding circumference. So today, you will have two different notes in front of you. We're going to start with the notes that has this circles on the front of it. We'll start with those. And then at some point in the video, I will let you know that we are switching over to our other set of notes. So by the end of this video, you will have completed 2 sets of notes. If you still have your notebook, be sure to glue in the notes. If you have lost your notebook, then be sure to keep your notes in a safe place so that you can look back at them later on in the unit if you need to. If the substitute hasn't given you both copies, just be sure to ask for the next set of notes, the circumference notes, when I get to that point in the video. So let's go ahead and get started. We're going to start with our introduction to circles. I am going to start with math antics. I know many of you don't like these videos, but he does a very good job at explaining things in ways that you can remember. So we're going to go ahead and start with this video so he can explain some of the terms, and then we'll talk more in depth afterwards.
Hi, welcome to Math Antics. We've learned a lot about geometry so far, but there's one really important geometric shape that we still need to cover, and that shape is a circle. Since the invention of the wheel, circles have been extremely important to all humanity.
Grog make wheel.
Thanks, Grog. In fact, you probably see circles almost everywhere you turn. But mathematically, what is a circle? Well, in geometry, a circle is defined as the set of all points that are equidistant, or the same distance, from another single point. And the best way to understand what that means is to see it in action. So, here's a single point to start with. And now, let's start drawing points that are equidistant from it. This point is a foot away to the right. Now let's make another point a foot away, but in another direction. Let's say up here. Now let's make another one, also a foot away, but in another direction, right here. Now let's make another, right here.
And another, and another, and another, and another.
Phew, I'm getting tired. But do you see what's happening? The more equidistant points we add, the more the pattern looks like a circle. And that's why a circle is defined as the set of points that are equidistant from a center point. But of course, we usually don't see it as a set of points because there's infinitely many of them, so they form a continuous circle. Okay, now let's learn about the parts that make up a circle. First of all, we have the original point that we started with. That's called the center or the origin of the circle. Next, we have the distance that we use to draw all of the equidistant points that form a circle. That distance is called the radius. The radius is important because it's the distance from the center of a circle to any other point on the perimeter of that circle. And even though a circle only has one radius dimension, you can draw as many radius lines as you want to. Usually you'll only see one radius line drawn since it's the same length no matter where you draw it. Another important circle dimension is called the diameter. The diameter is the distance across a circle. If you start at one point on the circle and then draw a line straight through the center to the other side, that distance is the diameter. As you can see, the diameter is really just the same as 2 radius lines drawn in exactly opposite directions. So for any circle, the diameter is always exactly twice as long as the radius. All of the equidistant points we drew combine to form the perimeter of the circle. Remember that perimeter is just the distance all the way around a shape. But because a circle is a special shape, the perimeter of a circle gets a special name. It's called the circumference. The circumference is the distance all the way around a circle. We're going to learn how to calculate the circumference of any circle in the next video. We'll also learn how to calculate the area of any circle. But before we can learn those things, we first need to learn about pi.
Grog
Okay, so we will get back to the video when we're ready to talk about pi. But first, we have some things that we need to write down. On the front of your notes, we have some space, and it's asking for the definition of a circle. So the definition of a circle is that it is a closed, two-dimensional shape that has no corners or edges. So take a second and write in this definition of a circle. If you need more time, please pause the video so that you can write the rest of it, and then press play when you're ready to continue. The video went over these different terms: center, radius, diameter, and circumference. We are going to label them on our own large circle. So open to the inside of your notes and you will see that you have this circle in there. Let's first label the center. As mentioned in the video, the center can also be referred to as the origin. The center is exactly what it is, or exactly how it's stated. It is the center of the circle. This center is extremely important whenever we are identifying where our radius and diameter would go. The radius connects from the center to an outer edge of the circle. You can draw the radius anywhere on the circle as long as it comes from the center to the outer edge. The radius is half of the distance across the circle. The whole distance across the circle would be diameter. So the diameter is from one edge of the circle all the way through the center to the other side. The most important thing to remember about the diameter is that it has to go through the center. I could not draw the diameter from right here over here because I did not go through the center. The diameter must go through the center. I tend to remember diameter and radius by realizing that radius is a shorter word than the diameter, so the radius is not all the way across. Diameter is all the way across. So that's just my way of remembering those two words. If that doesn't help you, sorry, but that's my way. Talking about circumference, before we identify where it's at on our big circle, let's define it. So right underneath your big circle, you see where it says the definition of circumference. So the circumference, it's a fancy name for the perimeter of a circle. It is the perimeter. It's the outer edge of the circle. But what the circumference is, or how we would define it, is the distance around the outside of a circle. So in that space provided where I'm asking you to write the definition of circumference, write this part that's underlined and in capital letters. Distance around the outside of a circle. Take a second to write that in. Okay, if you need more time to write that, go ahead and pause the video, write it in, and press play when you're ready. So the circumference, there's nothing you have to label on your circle because it is just the outer edge and it's kind of already drawn there. But you could, if you wanted, to draw an arrow from the word circumference just to the edge here of the circle. But that is what the circumference is. It is the distance around the outside of the circle. Circumference is just the perimeter. So let's do a little bit of diameter versus radius practice. You do not have this table on your notes, so you're just following along with me. I'm going to put a scenario up on the side here, and then I want you to consider, would this be a diameter or would this be a radius? Now, remember, diameter goes all the way from one side of the circle through the middle to the other side of the circle. Going all the way through the middle, that's important there. The radius goes from the outer edge to the middle, not through the middle. Our first scenario, When cutting a pizza into slices, the first cut is across the pizza through the center. Our hint here is through the center. So think about where you think this would go, in the diameter or in the radius column. This would go in diameter simply because it says through the center, from one side to the other, through the center. That is the diameter. The next example is the distance needed to swim to a floating dock in the middle of a pond. So if you pictured a circular pond, swimming from the edge to the floating dock in the middle, this would be an example of radius, simply because it goes to the middle, not through the middle. The next one, swimming across the middle of a circular swimming pool. Where would this go? This would be diameter because you are going across the middle, which is the same as going through. If you're going through the middle, it is diameter. The length from the edge of a button to the hole in the center. So if you're going from the edge of a button to the hole in the center, would this be diameter or radius? This would be radius because you are going to the hole in the center, not through it. The next one, the widest part of the circular opening of a washing machine. Think about this one. It's not giving you any hints of to the center or through the center, but think about how you would determine the widest part of the opening of a washing machine. This is an example of diameter because if you were going to measure the widest part of the opening of a washing machine, you'd have to go from one edge through the middle to the other edge. That would give you the widest part of that opening. At the top of a Ferris wheel, looking down to see the next set of people getting on the ride. So picture that you're at the top of the Ferris wheel, looking straight down. Would that be diameter or radius? This one is also going to be diameter because the people are not getting on the Ferris wheel in the center of the Ferris wheel. They're getting on the Ferris wheel at the very bottom. So if you're at the very top, looking straight down to the very bottom of the Ferris wheel, that is the diameter, straight through the middle. As displayed on a diagram, the distance from the Earth's surface to the Earth's core. This is going to be radius. If you're going from the surface to the Earth's core is in the middle of Earth. So if you were going from the Earth's surface to the middle of Earth, that is going to be radius. You're going to the middle, not through the middle. A walkway through the center of the garden. We have key helpful words here, through the center. We have another diameter. If we are going through the center is an example of diameter. One more. So the length of a bicycle spoke. So a bicycle spoke, these are those metal bars on your bicycle wheels. So you have to think, would a bicycle spoke go to the middle of the wheel or through the center of the wheel? This is radius. Your spokes, they go from the edge of the wheel to the center of the wheel. They do not go through the center, they go to the center. Okay, Mathantics is going to give us a little bit more information about pi now.
About pi.
Grog make pie.
Sorry, Grog, not that kind of pi. In math, the word pi, which is spelled pi, refers to a very special number. In fact, it's so special that it gets its own symbol. This Greek letter here is the symbol for the number pi. But if pi is just a number, why don't we write it like that? Why do we need to use a special symbol for it? It's a good question, and I'll get to that in just a minute. But first, let's learn what pi really is by seeing how it relates to a circle. It turns out that pi is really a ratio. Now, if you're not sure what a ratio is, you can watch our video about them. But basically, a ratio is just a relationship between two numbers that's written like a fraction. Pi is the ratio of two different distances on a circle. It's the ratio of the distance around a circle to the distance across a circle. And what do we call those two distances? Yep, the circumference and the diameter. So pi is the relationship of the circumference to the diameter. And as you'll see in a minute, because pi is a ratio, it's the same number for any circle, no matter how big or small. Okay, but what number is it? What's the value of pi? Well, to figure that out, have a look at these two circles, one big and one small. We're going to imagine that our circle's diameters are flexible like a piece of string, and that we can wrap them around the outside edges, circumferences, of the circles. So for each circle, if we start at the top and wrap the diameter around the circumference, we see that one diameter is not enough to go all the way around. So let's get another diameter and keep going where the first diameter stopped. Two diameters still isn't enough to go all the way around. It looks like we're going to need to get a third diameter and keep going. Oh, so close! 3 diameters is almost enough, but it looks like we're going to need just a little bit more to form a full circumference. That little bit more turns out to be about 0.14 diameters. That means that it takes 3.14 diameters to equal 1 circumference for any circle, big or small. So the value of pi is always 3.14. Well, okay, pi is a little more complicated than that. 3.14 is really just pi rounded off to 2 decimal places. And we actually have to round pi off because it's a type of number that's called irrational. An irrational number has decimal digits that never end and never repeat.
Grog confused.
Yes, irrational numbers are confusing. But seeing some more of pi's decimal digits will help you understand what I mean. To be more precise, pi is 3.1415926535897932338, and the decimal digits just keep on going forever without repeating. Pretty amazing, huh? But the good news is that saying pi is 3.14 is usually close enough for most math problems, so that's all you really need to memorize. And that's why we use a symbol for pi in equations. We could write pi with just 2 decimal places, or we could write it with 5 decimal places to be more accurate, or we could write it with hundreds of decimal places to be super accurate, or we could just use the symbol to represent the true value, which is infinitely accurate. Okay, so in this video, we learned what a circle is, and we've learned about the important parts of a circle: the center, the radius, the diameter, and the circumference. We've also learned about a very special number called pi. Pi is the ratio of a circle's circumference to its diameter, and its value is about 3.14 no matter what size the circle is. In our next video about circles, we're going to learn how we can use the number pi to find the circumference and the area of any circle.
Okay, so let's recap what pi is. As mentioned, pi is what we call an irrational number. It is an irrational number because it cannot be converted to a fraction. The reason it cannot be converted to a fraction is because it never terminates and it does not contain a consistent pattern. So when it comes to pi, it's very different than, for example, 1/3. When we turn 1/3 into a decimal, it has that 0.33333 repeating decimal. Pi, it's not a terminating decimal, so it keeps going forever, but it does not repeat any special pattern. It goes on with all kinds of different changes in numbers, no consistent pattern. We represent pi, or pi represents the relationship between circumference and diameter. Pi is the circumference divided by the diameter. We're going to talk more about the relationship between circumference pi and diameter in our next set of notes. There's one more thing on here. It's not on your notes, but just a fun thing to discuss. Mathematicians celebrate pi on March 14th. This is why we call this day Pi Day, because March is the third month and the 14th day, so 3.14. All right, we are on to our second set of notes. So set aside the notes that say circles on them and grab the notes that say circumference. It has this exact picture on it. If you don't have this set of notes, please go ask the substitute for these notes so that you can follow along and fill them in with me. Now that we know the different parts of a circle, we are going to discuss how to find the circumference. Before we full-blown start talking about how to find the circumference, we need to discuss diameter and radius just a little bit more. We need to discuss the relationship between diameter and radius. The diameter of a circle is represented with a lowercase d in formulas, and the radius is represented with a lowercase r. Now, the diameter is the full length of the circle, and the radius is half of that length. So in order to find the diameter, if I'm given the radius, I can take the radius and multiply that by 2. That would give me the diameter because the radius is half of the diameter. If I double the radius, I find the diameter. In this first example, it tells us that the radius is 5. So in order to find the full diameter, I'm just going to double this, 5 times 2, and I find that my diameter is 10. Now, on the other side, if I'm given the diameter and I want to find the radius, I can simply divide the diameter by 2, and that would give me the radius. If I cut the diameter in half, I'm finding the radius. So in this case, my diameter is 12. And if I want the radius, I'm just going to take 12 divided by 2, and I find that my radius is 6. So it's so important to remember the relationship between diameter and radius. Diameter is the full length across a circle, and the radius is half of the length. If you double the radius, you get the diameter. In many of the formulas that we're going to talk about, that is going to apply. We're either going to be doubling a radius to find a diameter, or we might be dividing a diameter to find a radius. To find the circumference of a circle, you might face 2 different scenarios. One, you might be asked to find the circumference when you are given the diameter, or you might be asked to find the circumference when you are given the radius. There are 2 different formulas. They are both on the screen right now. You need to make sure that on the inside of these circumference notes, you write both of these formulas on that top left side. The circumference formula when you are given the diameter is to take pi, we are going to use 3.14, times the diameter. So if you're asked to find the circumference and you are given the diameter, you're going to multiply the diameter by pi, and you will get the circumference. If you are asked to find the circumference when given the radius, you are going to multiply 2 times pi times the radius, and that will give you the circumference. Here's why. The diameter and the radius, remember that relationship. If you double the radius, you get the diameter. So up here where we do pi times the diameter, if I do 2 times r, I have the diameter. And then I just multiply by pi. The formulas are very, very similar because all in all, you are finding the same thing. You're doing diameter times pi. On this one, you just have to do one extra step. 2 times the radius gives you that diameter. And then you multiply by pi. So if you have the radius, 2 times pi times radius. If you have the diameter, pi times diameter. Make sure you have both of these written in before moving forward. If you don't have them written down, go ahead, pause, write them down, and then press play. Let's try a couple of these. First, let's try the formula when we are given the diameter. We have 3 different circles here. We're going to do the watch together. So I can see here that I'm given the diameter. It's the full length through the center, edge to edge. This is my diameter. It's 28 millimeters. So I'm going to substitute. I'm going to take D out and I'm going to put 28 in. Now, on my calculator, if you don't have a calculator, go ahead and grab one. I tried to put them out before I left, but you know how it goes. Sometimes they get put away or moved around. So make sure you have a calculator. You are allowed to use a calculator for this unit. In your calculator, you are going to type in 3.14 for pi every time. 3.14 times 28. And you will find that the circumference is 87.92 millimeters. We are going to, since this is essentially a perimeter, it's just the distance around the circle, we label with a unit of measure, just millimeters. It's not millimeters squared or cubed or anything, just millimeters. What's probably going to stress you out a little bit with this chapter is that most of our circumference answers are going to be decimals, but don't panic. You'll get used to it pretty quickly. Let's look at the next one. We have a pole here. To find the circumference, we have to do pi times diameter. In this case, our diameter is 14 feet across. So once again, I'm going to take D out. I'm going to put 14 in. On your calculator, type in 3.14 times 14. You should get 43.96, and this is measured in feet. So we have 43.96 feet for our circumference. Try this next one entirely on your own. Find the circumference of this dish. Okay, if you haven't solved it yet, please pause and then press play once you have an answer. You want to actually be trying these. That way you're ready for your worksheet. So I'm going to take D out and I'm going to put 9 in its place. So in my calculator, I'm going to type 3.14 times 9. And I get 28.26. And this should be inches. That's my bad. I should have typed that. 28.26 inches, IN. Okay, now let's try the other formula. Let's try and find circumference when we're given the radius. This time we don't have the diameter, we only have the radius. So for this formula, we have to do 2 times pi times our radius. Starting with this green one. So I see that my radius is 7. So I'm going to take R out and I'm going to put 7 in. So in order to find my circumference, I'm going to do 2 times 3.14 times 7. I get 43.96 meters. Something you could also do, which some of you may have noticed, is you can identify what the diameter is. 7 times 2 is 14. And then you can go back to the previous formula where we're just doing pi times diameter. If you do 14 times pi, you'll find that you get the exact same answer. Now, if what I just said is a little bit confusing, then just stick with the formula. 2 times pi times radius, you'll get the same answer. Let's look at the frisbee. At least I think it's a frisbee. Again, we're only given the radius. So I'm going to use the formula 2 times pi times radius. I'm going to take R out. I'm going to put 5 in. And now I need to do in my calculator 2 times pi times 5. And this is going to give me 31.4 inches. 2 times 5 is 10, by the way. That's the full diameter. And 10 times 3.14 is 31.4. Try this last one by yourself. plug it into the formula or find the diameter and plug it into the diameter formula. Either one's fine. Pause the video, solve it, and press play when you're ready to check your answer. Okay, so I'm going to take r out of the formula and I'm going to put 2 in its place. 2 times pi times 2 gives me 12.56 centimeters. So my circumference is 12.56 centimeters. Okay, so we also have to talk semicircles today. Semicircles are slightly interesting, and I have something I want you to think about for a second. A semicircle is half of a circle, but the perimeter of a semicircle is not half of the circumference. Why might that be? Why can't I find the circumference of a full circle and then just divide it by 2 to get the perimeter of a semicircle? Why doesn't that work? Some of you may notice, some of you may not. Every year there's always a mix of people who are very confused and people who see it right away. Here is why. This line right here, this line exists in a semicircle, but this line does not exist in a circle. So if I find a full circle and just cut it in half, I'm going to be missing this line. So a semicircle is not just half of the circumference. We cannot do that. So we do have a special formula when finding the perimeter of a semicircle. We have 2 formulas once again. We have the perimeter formula when given the diameter, and we have the perimeter formula when given the radius. So if you are being asked to find the perimeter of a semicircle and it gives you the diameter, your formula is to take pi times the radius plus the diameter. Here is where we have to remember that relationship between radius and diameter, because we've just established that it's going to give you the diameter. It's not giving you the radius. So how could I find the radius if I'm given the diameter? I can divide the diameter by 2, and it gives me the radius. So even though I'm being given the diameter, I still have to do a little bit of work to find the radius. On the flip side, if I am being asked to find the perimeter of a semicircle and I'm given the radius, I'm going to do pi times the radius plus 2 times the radius. These addition parts of the formula, these are going to be what gives us this line. So we're either adding the full diameter or we are adding 2 times the radius, because that's one radius and another radius, 2 times the radius. So that's what these little addition portions of the formula are giving us. We're adding that piece back on. Let's try it. Let's see it in action. So we have a semicircle that's giving us the diameter, and then we have a semicircle that's giving us the radius. So we have 2 different formulas that we are going to be using. For this first one, it's giving us the diameter. So we are going to do pi times the radius plus the diameter. First, we have to establish what would be the radius. If the diameter is 2, what would the radius be? 2 divided by 2 is 1. So my radius is 1. So if I want to plug this into my formula, pi is going to be 3.14 times my radius, which is 1. And now I'm going to add the diameter. 3.14 times 1 is 3.14. And then I have to add 2. 5.14. So the perimeter of this semicircle is 5.14 feet. Over here, we're given the radius. So we are going to use the pi times radius plus 2 times radius formula. My radius is 15, so I need to plug it into 2 places in this formula. Pi, 3.14, times my radius, 15, plus 2 times my radius, 15. I need to follow order of operations here and not make any silly mistakes. I need to do all multiplication first before I add anything. I need to start by doing 3.14 times 15 and then 2 times 15. 3.14 times 15 gives me 47.1. Notice how I did not just add 2. I have to come over here and do this multiplication. 2 times 15 is 30. Now I can add them together and I find that the full perimeter is 77.1 inches. So a lot of what you're going to do on today's worksheet is applying the formulas. I completely recommend that you keep your notes out in front of you so that you have access to your formulas. I want to show you today's worksheet. You are going to have circles and you're going to have semicircles, but you're finding the circumference or perimeter of either one. Now, here we have a circle and it gives us the diameter. So I need to use my formula. I need to look at my notes and find, okay, circumference of a circle. I have the diameter. What's the correct formula? You're going to solve the problem, show your work below. I give you space to show your work below. And then on the back, on the bottom of the back side, you have an answer bank. So when you solve this first problem and you do pi times diameter to get your circumference, you're going to find that answer in this answer bank. By the way, it's 18.84. There's your first one. You can cross this out because it's only going to be used once. So you'll solve this one, you'll get your answer, you'll go to the back side of the paper, you'll make sure that answer exists. Because if the answer doesn't exist that you found on the back of this paper, then you've made a mistake. That's not the right answer. All of the answers to all of the questions on this paper exist in this answer bank. So if you try to find an answer and it's not down here, you need to resolve that problem. Maybe you used the wrong formula. Maybe you typed something wrong in the calculator, but the answers, they should be in this bank. So you can cross them off as you go. There won't be another question that's 18.84. Once you use it once, it's done. That way you can kind of have a better idea of if you're getting these answers right. Because if you see it in the answer bank, you got it right, you can move on to the next question. If you don't see it in the answer bank, try that problem again. A mistake was made. These questions down here, for these, they don't give you a picture, but they are still questions that you need to answer. It's telling you that it is a semicircle, and it's telling you that the diameter is 3. So it gives you all the information you need. You know this is a semicircle, so you need to look at those formulas, and it gives you the diameter, so you need to get the formula for a semicircle when given the diameter, and you'll find this perimeter. This one, it tells you it's a circle, so you're looking at your circumference formulas. And then it tells you that you have a radius of 18. So grab the correct formula, solve for it. Those answers are also located down here in the bank. So don't forget to do these simply because they don't come with a picture. You're still finding the circumference or perimeter of these 5 items as well. When you are done, make sure that your name goes on this and then you put it in the bin. And then if you have any time to spare, you need to be on Get More Math or completing work for another class, but you should not be on any random games at all, okay? If you have any questions, make sure that you write them down or remember them so you can ask me tomorrow.